hobbies the other night. I told her I've been in an astronomy club. Gave her a link to
Just Tom first, then you, then Wayne, and then the other two. I have the files listed in order. Actually, it's in order in the presentation.
These batteries lately, they were getting real funny last year.
Is it not working?
Oh, no, I can try. I can try.
Yeah, let's check it out.
Hear anything? Yeah. Is it working?
Hearing that. Might be dead. Let's see if we have a battery.
Is it a 9?
It's in the bottom.
The Chinese puzzle box? Is this a?
Check this one. Yeah, it's got voltage, but not. Battery in. Plus this. Yeah, plus this for that one. There we go.
Okay, we're going to get rolling here. So thanks for coming out tonight. To the December 13th meeting of the DVAA Amateur Astronomers. My name is Tom Delasco. I'm the backup act for tonight. Jan couldn't make it. So this is oh, we got the scrolling on there. You want that?
Oh, yeah.
Okay.
Captions.
Okay, why not? This is an image of the Superman galaxy. It's right below the bottom right-hand star of the square of Pegasus, Alpha Pegasus, right about 2 degrees below it. And in a scope, those arms are a little tricky to see, but you can see it. You can see the center area, the bulge, and the bar structure. That's bright enough to see in a small scope from like Green Lane. But to see the rest of it, you need a really dark sky and a little bigger scope. Anyway. Okay.
Try it now.
Okay, upcoming events. Last month, I told you the annual business meeting was on December 15th. Well, I lied. It's actually January 4th. It had to be rescheduled. So there will not be a business meeting on the 15th. If you go to the events calendar, you'll see on January 4th, it's going to be here. It's between 1 to 3. It's a Saturday, the 4th. And all members are welcome. Where we go over what we did right, what we did wrong, new things we want to try, go over the budget and things like that. But it's good. If you have any ideas for changes or new things, come on out. We're always looking for new stuff. We have a January 8th astrophotography workshop. That's a Zoom. That's the Wednesday before the main meeting, which is on the 10th. And we have 2 clinics in January. The first is electronically assisted astronomy, which is for those who want to know more about these smart telescopes, in particular, if they want to see them up close. We should have a C-Star S50, Vespera, a Unistellar, a Dwarf 2, maybe the new C-Star S30 might be here too. What's a chance to see things, see what they can do, compare models. We'll have some breakdown charts. We'll show images that club members have captured through these various pieces of equipment. And if it's a sunny day, we'll go outside and we'll look at the sun and we can show you the apps. If it's not sunny, we'll show you the apps inside and we'll show you how they work and you get a feeling for things. The 18th, there's the solar observer, there's 2 sessions. First session is solar observing. I'm gonna go over different things you can see on the sun and ways to see them, as well as to photograph them. And later on in that day, we have the binocular observing, which goes over, what you get from different kinds of binoculars, good objects for binoculars, and things like that. That should be a good workshop. But I have a little note there. If you're planning on attending, please register as soon as you can, because we're trying to get, it helps us to customize the workshop a bit and to know how big of a group it is and all. So if you're thinking about you might register, you might come, then please register soon. And then we have a astrophotography workshop in February and the meeting in February. Okay, you've seen this slide before. Hasn't changed from last month. The big thing on your, like the water start party, actually, they're still taking registrations. But the main thing is that main sequence star party, Big Dipper Lodge, and Little Dipper Lodges. We do these in the spring. Bill McGeaney helps set all this up. And there is one in the spring, one in the fall usually. One in the fall, we had really good weather. It was spectacular. It's a load of fun. It's probably only 2,000 feet down the road from Cherry Springs State Park. It's the same sky, but it's our own private field. So it's really nice. Highly recommend it. I thought I mentioned this, Mountain Planetarium. I got the schedule for January. There's two shows on the 9th. They do one public night each month. And in January, it's Thursday to January 9th, and they have one earlier program that's Celestial Highlights and the film Two Small Pieces of Glass. And then there's a later show that has the Celestial Highlights and the Mars Opposition. So that's always kind of cool to check out. Okay, last chance to vote. Election ends tomorrow. If you haven't voted, why haven't you voted? So if you remember and you still have the email with the link to push the button, please vote. Okay, I'd like to get Al up here and John. That's you, John. Yes, John. That's me.
The Astronomical League has a number of observing programs. One of them is the Messier observing program. There's 2 levels. You look at or observe 70 Messier objects. You get a silver certificate. Another 40, which John is going to get very soon, I hope. You get a gold certificate and a pin. So John has observed 70 Messier objects without any electronic assistance. It's all point and shoot. And he recorded it, made his observations. Now he has his first certificate, and hopefully one of many. Okay. Congratulations.
Okay. Every 3 years or so, we have an auction typically. We've been having these auctions. And the thing is, if you wait 3 years and you get all these scopes donated, the storage unit fills up. And then people's garages fill up, and then basements fill up. And then somebody says, we have to have an auction. And we go there and we're trying to find what parts go with what. And it's a real effort, and it's a lot of work. And so we decided this year to go with the classified ads. They'll be in the website. You see the very top there. There's a little button you hit, classified ads, and it has a listing of a lot of nice telescopes. Whether they're just the optical tube assembly, complete scopes. There's eyepieces, Barlows, filters, all kinds of stuff. And these are at really good prices. These are below the prices you would see for a pre-owned piece of equipment on like AstroMart or Cloudy Nights. They're good. They're priced to sell. And if you're thinking about equipment or thinking about a gift, just go to the website there. And that money isn't going to spend itself, tonight in the back, we have a couple of these items. These will be the smaller items, less than $30. I think we're not gonna put on the website. A couple of these might be. But we have a variety of these back there. All of these I think are in the back that are available for sale tonight. You just go back and give Scott your money. He'll be glad to take it. But so some nice equipment there. Nice filter sets. You got the planets coming around, prime planet time. There's 3 different sets there. They can buy one set for $20 or the whole lot for 50. Okay, reports. Brian Lee.
I'm Brian Lee, welcoming chair. For the month of December, we have 7 new members. Donald McKenzie, Joe Catalano, Edward Murray, Nathan Wright, Sasha Burton, and Joseph and Patty Rahai. So if is any of those people here tonight? Oh, all right. Thank you. You're welcome.
Okay. I don't think Ken made it tonight. He was going to be in the table there, but Ken has agreed to be the outreach chair. Al has been kind of filling this position as an interim position for a year now, but so Ken's going to take it over, and that'll be a good thing. The newsletter committee is looking for an additional editor. One of our editors is retiring at the end of this year. That's Dana. Her last issue was December. She did it for 3 years and did a great job. And we're looking for a 6th person. That way everybody does 2 months, or even just just want to do it for a single month as a guest editor. If you want to just give it a try and you got some ideas of what would be nice for the newsletter, then by all means, contact anybody on the newsletter committee. Others. Is there any other chairs who want to say anything tonight? I think Bill, I think this is right, but Bill, there's been talk about a trip to Cyprus in 2026, very loosely started talk. There's an amateur astronomer there who we see him 2 or 3 times on Zooms in the astrophotography meetings. And he's in charge of a couple of observatories there, and there's one brand new one that's really nice, and he does a lot of imaging. And he's invited anybody to come. Anybody can come over as a group or anybody by themselves and be at the observatory and enjoy it. And so there's been some talk about some people maybe trying to get a trip together in the summer of 2026. But that's just in the very preliminary stages. But I just wanted to mention it. Get your wheels turning.
Certainly for everybody.
Yeah, it's everybody's invited. I mean,
Yeah,
Cyprus, nice island.
The best time, I only want to get a hold of it. It does get very, very hot, and we want to do it on a season where the winds from the Sahara are less prone to cover the island.
So anyway, there'll be more news about that as it goes on. We'll just kind of throw it out there to get the idea out.
Yeah, everybody in the club should go.
Okay, last month we started to think about membership. Now it's time to get serious. It's the end of this month. The membership renewals are in January, so see what you can do there. Suddenly I'm dead. I give up.
Lose focus right now.
Okay. There we go. Okay. Tonight's a members' night, but we're going to start off with an observing talk by Bill McGean, past president, on the solar system highlights for this upcoming year. So Bill, why don't you come on up?
Okay, how's everyone doing? Yeah, so we're finally here at the year 2025. It's upon us. One thing I want to say to piggyback on what Tom said about the trip out to Cyprus, I know there's been also talk of other big trips, say like out to the Southwest. These are things that are kind of pie in the sky for us. But if you're interested, like I need to have some understanding of who will be interested, who will be up for it. Usually it's a small group, but that's fine. We just need to have, like please reach out to me, camping@dvaa.com or .org is the best way to do it. So let me try and use this thing. I will fail miserably at it, but as you can see, is upon us, 2025. And this, yes. All right. This is the point. So something, Jeremy, what am I doing?
That's going down buttons.
I don't need to go in.
It's always the opposite one that you think.
The down one. Okay, so starting off, right, 2025, since we're in the solar system. We have the solar maximum going through 2026. We are here. And it is winter time. It's the best time. If a miracle happens and we get another blast from the sun, we could be seeing something like this. So the first thing you need to do right now, if you don't have, you have to have your emergency prepare kit, the Aurora prepare kit, so that way you can grab it, go that night. To take that last shot, actually, my wife Caitlin, she actually had pretty much planned everything. We had everything set up, ready to go when I got home, and we bolted out of the house and we were able to get upstate in time to hang out and see the eclipse the Aurora without any problem. And we spent pretty much the whole night enjoying it. So make sure you have things like, you want to have, blankets and warm, good chairs, and, you want to have really warm clothes because it's probably going to be windy and cold wherever you're at. It's nighttime, right? So make sure you have your headlamp, and of course, bring something fun like a hot chocolate or something. Make sure you have your food staple. You don't want to not have food, right? You don't want to like starve yourself out there. You want to make sure you're going to survive this. So I always go with the peanut butter pretzels. Solid, nice resource, a lot of good dense calories in there. It's good for just survival. So highly recommend it that you have your kit ready to go. Make sure the camera, tripod, everything you need, it's ready to go. Okay, next up, what else do you need? Of course you need an app, right? So there's multiple apps out there. I'm not going to say which ones are good or bad. The one that we used was the My Aurora forecast. It was adequate, right? You can get it on any of the app stores out there. It's the one with like 46,000 likes of 5-star reviews, which makes it even less believable. But anyway, they have two main indexes that are going to tell you what's going on and what the probability is. The K index, which is a 3-hour index, is going to 3-hour window. It's going to say, hey, you know what, the KP is going to say sometime in this range you're going to have a peak, and it's not going to be sustained through the whole thing, but you're going to have a probability of a peak sometime. And then you have the HP index, I think I have that right, which is going to be the 30-minute window, and it's going to be more detailed down to a precise time. For our purposes down here in Southeastern PA, it's not often that we have that amazing blast that we had in October. So if you're doing something that looks viable, you're probably going to have to drive. So I don't think, having something precise is going to be a big deal for us, because you're rolling the dice anyway, wherever you're going to go. It's going to be many, many hours in the car. Okay, so that's starting off. Now, let's talk about the rest of the solar system. So in January, we actually have some really cool, there's a lot of really cool stuff you can see. And I don't know how many of you guys actually do any binocular. Does anyone here still do binocular? I'll do binocular. I love binoculars. I think I'm even doing the clinic. I think I'm helping out with that on the binocular side. So a lot of this stuff is stuff that if you have binoculars, especially high power binoculars, you're going to have a field day with. But here, right, starting out the year, we have Venus within 3 degrees of the moon. And this is, I think this is, I want to say this is towards the end of the night. No, beginning of
Evening.
west. Yeah, this is the west. It's evening. Yeah. Yep. So this should be right after sunset. Yep, okay. So that's a good way to start out. Then the next night, you actually have Saturn and the moon, and they're gonna be right next to each other. So hey, within 2 nights of each other, you have really good little visual setups of the planets and the moon, and it's a pretty moon. It's not, in my mind, a full moon. It's nice, but it's not, it doesn't have character, right? We got contrast, we got personality with the moon when it's in its phases. So, you know, that's a nice little haul. And then on the 13th, the day after my birthday, what a nice treat. Assuming it's actually clear for a change. There's an occultation of Mars by the full moon. And this should be really fun to see. Happens at a good time. It's 9 o'clock, 10 o'clock, you know, everyone's awake, you don't have to stretch your night out. And you should be able to, this should be a really fun time to see. And let's move a little further into March. March, we have 2 eclipses. The first one, we have a total lunar eclipse. And again, this assuming if we have decent skies, always a miracle here if we have any kind of good skies in any of these events. We'll see in typical fashion throughout the middle of the night, you know, the middle early morning hours, you'll see the best stuff coming along. So make sure you circle that day on your calendar. Hopefully, you know, again, we get good weather. And then I know there's some people here who like to go to Assateague. This might be a great excuse to go to Assateague. Have a fun night of observing, do some astrophotography, and then sunrise, you have like 10 minutes to see a little tiny piece of the solar eclipse. So highly recommend it if you want to be out there. Dress warm because it gets very cold when there's wind on the beach down there. But hey, you know what? It's a nice way to cap out your night if you're down there, right? Okay, moving on to April. We got a lot of triangles in this month. So anyone who's in astrology, maybe you can tell me something about what all this means. But here we have Venus on the right side of the home plate of Pisces, and you have Mercury and Saturn almost forming an isosceles. So it's kind of neat to see. You can, you know, get out there. If you're an early riser, you're driving to work or whatnot, you know, you look up and you can just see this right outside your door. What's better than that, right? Mercury is going to be featuring a lot in January and in April. So definitely enjoy it. April, we also have the Lyrids, which actually have a very favorable moon this time around. It's going to be just a little crescent. So you should be able, you know, again, if miracles happen and it's clear here, or I think that's right. Is that our time up? Somewhere near our time up in Cherry Springs.
Very close, yeah.
Very close here. Yeah. So, you know, maybe we might get a nice little meteor shower too up there if we get lucky. Okay. The 25th. This is a really nice visual. Just nice little isosceles with the moon dead smack in the middle, a nice little crescent moon. I mean, what more to say on that? You can't beat that. That's half the solar system right there, just hanging out. Then we have in July 6th. Again, if you're up Cherry Springs, I know we have a short window during late June, early July of stargazing. And this falls into like your 5-6 hour window that you have. You know, you're about ready to break things down another hour. It's 3:15. You're up and you see Venus. And if you have a good binocular set, or if you have, you know, just a medium power telescope, get Uranus, and then you also have Pleiades right there. What a better way to end your night than to have that? And it's real simple, nice, pretty visual. That's great. November 23rd. Saturn goes ringless, sort of. Definitely see if you can find it. But hey, you know, it's got to celebrate the time we're in, right? You can't expect to see rings all the time, guys. Come on. And then we get to December 13th. Geminids have a favorable moon phase. I didn't mention the Perseids because they have a full moon. So if it just is what it is. So, but Geminids, which are happening this weekend under the full moon. So when you're not looking at your drones, maybe you'll be able to see some shooting stars. Okay, to remind you, the April 23rd through 27th, we have the field trip, and this is always a good, yes. This?
No, I didn't see.
Oh, yeah, I haven't published it. Yeah, it hasn't been published yet. No, it's just been me being too busy and not getting around to it yet. So yeah, keep harassing me and I'll get to it. But yeah, 23rd through 27th, April. should be a good time of year. We've done it before in April, knock on table, and we got at least one spectacular night. The other night's not so great, but you know, anytime we go up here, I just want to say this is a costly trip. These field trips, unfortunately, due to the economics of just the rentals up there, they're not cheap. You are rolling the dice. I can't do anything about that. I wish I could. If that's not your thing, I get it. I mean, it's, I'm not a huge fan of it either. But that is what it is, that the club tries to subsidize where it can. But it is going to be pricey, and you know, April is a really fun time to be up there, especially when we have meteor shower within 2 days of that. It's, if we have really good skies, it's going to be a really good time. And then one thing that I didn't hear mentioned, we have AstroCon, which is in a place that, and I know we have folks here that can vouch for stargazing off Rainbow Point in Bryce Canyon. It's back at Bryce Canyon this year. Hey, what a better time to go to AstroCon. And this, you know, you definitely check it out. The Astronomical League, this is their event. They have talks, they have presentations, they have exhibits, they have a whole bunch of things going on, and you get to stargaze in one of the most amazing places in the lower 48. Definitely put that on your calendar. I don't know if I'll be able to make it, but that, if you are curious about it, or if you have any inclination, do it. That is one event you want to do. And then, of course, you can go to our website and see all the other events going on. And, you know, we have Astronomical League lists. I'm really glad to see John. Nice work. One I just want to talk about real fast here. Since we're talking about the planets, you know, we have 2 lists out there in the Astronomical League that deal specifically with the planets. One is Jupiter. It's not really going to be that great. I believe it's, Al, correct me where I'm wrong. Where's Al? Yep, Al, correct me where I'm wrong. That's only based on certain time frames for Jupiter, right? And it's the same with Mars. But the Mars piece, the occultation, you can knock out this year. So the Mars Astronomical League piece you can knock out because we have it coming up, assuming we have skies. Jupiter one, you have to wait till 2026. But the other one I want to mention is the asterisms list. This is something that I did in Portal 8-9 Philadelphia. You can do some of these visual lists. You don't need to do like super deep objects in areas that, you know, are murky as anything, but you can do some of these visual lists that only require binoculars, or they require just a subtle modification, like subtle magnification for different things. So I am a huge fan of this asterisms list. Completed, I would say, no, I want to say half of it in Philadelphia, and complete the other half in different various places. But it's one you can take with you, and you don't need to pack a lot. And you get to learn more about your night sky, and you get to learn more about everything around. So highly recommend that. And that is all I got, as with the apparent black screen. So Jeremy or Tom, whoever wants to MC, feel free.
Well, probably. It's just the until self-flight polar bears. What's that? Until self-flight polar bears.
All right, good evening, everyone. So for tonight's meeting, we're going to have a member night, but I guess first we're going to do a little preview. For January, we're going to have Dr. Becca Phillipson, who's a new professor at Villanova University. She's going to talk about chaos in the cosmos. So, you know, about chaos theory and strange attractors, the butterfly effect, those sorts of things. So we'll learn about where that appears in the universe. So tonight, I thought, since we have a lot of activity going on in the solar system with the moon, the sun, the planets, thought we'd have some of our observers come up here and tell us about planetary observing. So we have 4 folks coming up tonight, and first up will be Tom Nolasco.
Okay, I'm back. Here you go. We're going to work this. This has 3 major sections, basically. A little bit about the plants, which you can see, then equipment and like tips, and then a little bit about seeing. So we'll get right on with it. This is the way, now there's something wrong with this illustration, which you can, that looks a little weird. The fact that Venus and Mercury are going around the sun the same period around their orbit, that's really not true. That's off by a factor of 2 there for one of them. But anyway, but it gives you an idea of what the alignment is. So when it's far away, when it's over here, it's almost full, the inner planets, and then it gets to a real thin crescent stage. And what this looks like through a telescope, this is Mercury. It looks like it grows from but it grows from a full to a crescent phase. Mercury's tough because it's not that big to begin with. It's 4.5 to 13 seconds. Now to spot it, for me, it's always easier to spot it if it's near something. This was up at Cherry Springs a few years back. It was close to the Pleiades, easy to find. Here there was a conjunction with Mercury and Saturn and Jupiter. So Jupiter was pretty bright, it came out first. If you kind of know where things are going to be, you can pick them up real easy. And through a telescope, it looks kind of like this. It's not too much to see, but it's still, it's kind of like one of those things you put a notch in your belt. I saw Mercury. Venus, same kind of deal. And but it changes, it gets a lot bigger. It is, it's in that 9.7 to 66 seconds. So that's really big. The time between either superior or inferior conjunction to where it gets back to where it starts again with the original size is about 19 and a half months. But a lot of things happen at the end. It's more interesting as it gets close to the crescent phase. This is over a 5-week period that these images were taken. And you can kind of see, the crescent that kind of wobbles over top because in this case, it went below the sun. So the crescent starts to go on top. And the neat thing about Venus is, because it has an atmosphere, the horns begin to extend and you can see some of the atmosphere come around the edges. And that's always fun. This is a shot I saw just a couple of days ago. I put it in here on space weather. This fell in Chile, at UCO Leon, down in San Diego, went and took a picture every day from March 23rd to October 24th and just put a scaled sun in there. And it kind of gives you the view for where we are. We're on the Earth looking at Venus, and as it goes around, you can kind of see the size difference and how the crescent and everything goes. That was a nice little capture there. And while we're here, observing, there's a site in the sky.org. Just put that, type in the sky and you'll get this. And this site is loaded with observing tools, just tons of them. And my favorite part of all of these is what I use is it's where they have all the ephemeris. And you can go in there, and what it does is you can put in like an object, in this case planets. You can choose your object, you can choose the number of rows you want to get, the time period you want to get, and choose the different pieces of information you want to see. And this is what typically I would look at if I'm looking for the inner planets. I'm looking at how far is it from the sun, what's its diameter, you always get the magnitude there, but the phase as well, and the coordinates. So if you're going to Venus in the daytime and you're being real careful, and you can put a solar filter on the sun, get on the sun, and then offshoot from the sun's coordinates to Venus's coordinates, and you can find Venus that way. I wouldn't advise it when it gets too close to the sun, like less than 20 degrees for sure. Visually, probably 30 degrees is about as close as you want to get in the daytime. I've done less, but only with cameras first and all kinds of equipment to be safe. But it's a great site. And this is good for Mars too, coming up. But you get to see what's the size of Mars, what's it going to be, and when's it going to cross the doggone. We're struggling here, aren't I? The center column is the meridian time. And that's very interesting because you always want to try to observe the planets at the highest point. So anyway, Mars. Mars is one of those planets Mars is kind of a pain in the neck to me. It only gets close to there's opposition every 26 months. And the kicker is not all oppositions are the same. This opposition, look how close it is. But if the Earth was here and Mars was there, it's not nearly as close. So when we have opposition, it's not as big. So each pass every 26 months, the size of Mars varies. And unfortunately, we're in a cycle where it's going downward. This is kind of how it looks in just through a telescope. You can see very quickly, this period here this year is only a short period of a 2.5 months really, where Mars is greater than 12 seconds of arc, where you can kind of see things up a little bit easier. And you can see its size. This is always a killer at star parties because Mars will be up in the sky for the entire summer for us. People are gonna say, I wanna see Mars. And what they're gonna see is this little 3.5 second disk. So it's a shame because they won't see the polar caps or the albedo features. But last year, or 2 years ago, and change, Mars was about this size. If you scale it down for this year, 17.2 seconds of arc, 14.6 max. So on December 26th, it's gonna be pretty big, and the 12th is probably close to the biggest. And the later on in February, it's already starts to shrink quite a bit. So right in this January is the month for Mars. That's where you'll see the most detail. And this is a cool tool. Sky Telescope has a few of these really nice tools. This is the Mars profile. If you just type in, there's a long web address there, but if you just say Sky Telescope Mars, you'll probably get a link to this, or if you type Mars profile, you'll get this. And so depending, you can set it up so that, you know, for every hour you're going to be out there, it's in universal time here. It's 5 hours difference. So if you want to observe at 8 o'clock at night, you look at one o'clock the following day. And so that'll give you, it shows you what area of Mars is facing the Earth. This is the central meridian of Mars at that time. And it's got nice features because it gives you a direct view of this map, or you can say, I have a Newtonian, so I'll look at the inverted view, or if I have a refractor with a diagonal or an SCT, I can click on that button and it changes the map to match what you'll see in the eyepiece. So you can identify what you're seeing. Jupiter. Jupiter's the big winner. Jupiter is always good. It's got so many things about it. It rotates fast, which is nice because you can see several different areas of Jupiter in one evening. The cloud bands, the equatorial belts show up really well, even with the smallest telescope. Larger telescopes, you see more and more detail. You have the red spot. Red spot's always cool. Keep hitting the other buttons. The red spot, this varies radically. It hasn't shrunk a lot. Back in, when I first started observing, back in the late 1960s, the darkest feature and easiest feature to see was the red spot. It was so dark and so brick red, and it was large. It was like this big. It was really long, very elongated. But it's gotten a little, it paled out for a few years, and now it's gotten a little more orangey now. So that's what's, and the moons are great. But Mars rotates fast. How fast? This is in 4 minutes, it moves that much. That's Ganymede off to the side here. It's moving, that's its shadow. But you can see how much it moves just in 4 minutes. So if you're out, you can look at Jupiter when you first go out and kind of keep a note of where things are, and then go out an hour or two later, it's going to look a bit different. Tools, once again, Sky and Telescope. Type in Sky and Telescope, Jupiter's and moons, you're going to get this interactive chart. There's two different, the Sky Live also has a site, has a prettier graphic, but I like Sky and Telescope because it has the moons, the events on the moon, the moon events about transits, shadows, occultations, when it goes into the Jupiter shadow, that's all seen here. Now remember, all this stuff is universal time. If you're going out on the 25th, you want the date to be the 26th, and you can look in here for things that happen early, like around 0 hours UT, that's 7 o'clock at night, you know, or 1 o'clock or 2 o'clock, and look for those events here. You can barely see it probably here on the screen, but there's a little shadow of Io or somebody there. But this is a great tool for planning your observing, or just to see if you can see it. If you have a small scope, it could be hard to see the shadow. If you got a little bigger scope, like a 5 or 6 inch, it's gonna be pretty easy to see and really nice to see those shadows go across. And they cross quickly. The whole event from start to finish is like an hour and a half. Another observing tool, Sky and Telescope again. Type Sky and Telescope red spot, you're going to get, you'll get either this directly, you'll probably get an article that in the article, as you scroll down, is going to have a linked interactive tool. You just hit it for today. This is nice because it gives you the local time as well. You can say, okay, there's going to be, this is the central meridian when it's right smack center time. So at 9:18 on the 25th, it crosses. Now the following night, if you have it one night at the prime time, the next night's not going to be there because it takes about 2.5 days to rotate. But this is a great tool. Then we have Saturn. Here's Saturn's, these are 3 Septembers in a row here, bang, bang, bang. 22, 23, and 24. You can see the rings closing. This is a great animation by a guy named Alan Friedman. It's a whole series of images covering roughly 6 years. And but it's a beautiful animation showing the rings going edge on. Now the rings really hit edge on in March when it's too close, Saturn's too close to the sun. But we kind of luck out if you like very thin rings in that in next November, December timeframe, which Saturn is going to be really nice, it goes almost edge on again. It's less than a 0.5 degree tilt. Right now, you look out and look at it, it's probably about a 3.5 degree tilt. So it's really, it should be pretty cool then too.
Hey, Tom,
Yes,
who took those images?
what, on the left?
Yeah,
That's a great photographer in the club.
and his name is?
Name is Tom Nolasco. But once again, tools, sky and telescope. Sky and telescope, Saturn's moons. And one thing good about having a very thin ring, besides looking kind of interesting, it's not as good for the public probably, but the inner moons are easier to pick up. I think talking to Jeremy last month, he saw Enceladus, I think, pretty easily. And these guys hang kind of close sometimes and are blocked by the rings, or just the brightness of the rings is so much, is kind of like the glare in the eyepiece. So it's a good time to look for those inner moons. It's kind of a bonus time.
Hey, Tom, could you go back to that animation of Saturn for a second? I was just looking at the shadow of the disc, so you can see it looks like it's taken
Oh, it's all different.
just past opposition.
Yeah, it's close to
Each year.
opposition. Pretty much all on the same side of opposition. Anyway, so there's tools like that. Yes. Now, this is for those, the planet itself is good to find, just to see it, and you can kind of get a feeling of what William Herschel experienced. But it's the moons are tough, but doable. Now, the only ones that you really have a real good shot at are Oberon and Titanium. Those two, and those, when they're further out, they're easier to see, but they're faint. These guys are like 13th, 14th magnitude, so they're not going to be a walk in the park. You're going to need to go to a deep, dark site, at least 8 inches. If you have a larger scope, you got like a 12, 10, or 12, you got a lot better chance. The other two, they stay closer to Uranus, and it's you're going to need a big aperture. It's small. Well, look at the size of that. The size of the planet is similar to Mars when it's most of the time. So it's pretty small, but everything moves a lot quicker than you think it does. This is only 1 hour and 50 minutes. Now, it's not the greatest images in the world, but I wanted to see if I could see things move. So this is just through a 6-inch telescope. And you can see the moons, the other 4 moons there. You can see them rotating around. It's kind of blobby there. But what surprised me, this is the close-up. This is the same image here. This is the whole frame, though, is how much Uranus moved in 1 hour and a half. These are the background stars, these 5 here. So the observing challenge that I put out there is for those who want to do what William Herschel did. William Herschel stumbled upon this. Noticed that star was out of focus, basically. It was around his disk and it was a little bit greenish. And he thought it was curious, and he marked it down. But he went back to it because it was kind of a weird little object. He was thinking maybe planetary nebula. But he went back to it and it moved. So he came to the obvious conclusion that it was a comet, which was obvious, right? It's moving. So, however, as more observation came in over time and the mathematicians got involved and started to realize its orbit was like a planet, that it truly was a planet. And but it's kind of neat if you were just to sketch it, just try to sketch it against the background stars, and then go at it like a night or 2 later and do it again, and you'll really see a difference. There's tools again, sky and telescope, Uranus. There you go. And this would be a good time to, if you're looking for those moons, these 2 guys, O and T, Oberon and Titania, you get them when it's like far out like this, away from that glare, because even though that's 6 magnitude. Comparison to these guys at 13, 14, it's glare, it's bright. Okay, the telescope's best. These kind of pictures always amaze me because I'm looking at this, you think about wobbly mounts and things like that. This guy has ropes. Look at the length of this tube. Now it's not an achromat probably, it's just a single lens. So his tube is forever long to get rid of the chromatic aberration. But to do that, you need this ridiculous mount. With all these ropes and wires, and his field of view has got to be infinitesimal. And yet he's trying to, use this system. I don't know what these guys saw. Amazing. So what pipe is better? That's kind of a loaded question. Up for a lot of debate. But in general, I'll tell you that the little smart telescopes aren't the way to go. All they'll give you, like the moons of Jupiter, you can kind of log those down and get those pretty good, but you're not going to get detail on Jupiter or Saturn or any of those things. So they're kind of out of the picture. If you had a choice, you have a reflector. If you had a choice between these two reflectors, that's the one I would choose. Even though they're the same diameter, say, of aperture, I would choose this one. This one's going to have a smaller secondary mirror, which means smaller mirror means less diffraction, less light scattering. It gives you a much better, it doesn't disturb the light coming in as much, so your peak to valley wavefront is better. So that's the one thing. Schmidt-Cass's, now that being said, Schmidt-Cass's have a huge secondary obstruction, 33%. And you go, wow, that's got to be terrible. But I'll tell you, some of the best amateur pictures that they've taken in the world are taken through Schmidt-Cass telescopes. So they do work quite well. And in this case, for refractors, I showed the difference between the two. It's kind of old school here. But a long refractor, this is probably an achromat, and that's probably an apomat. But it's just easier to get higher power. On the planets, you want to get higher power so you can see the detail. If you're looking at like 100 power, 80 power, they're pretty small. It's harder to pull that detail out. But there's a power meter in the back that's 5x that you can buy for this scope here and get you up there. Okay, the eyes of the telescope. Now, this is where it gets a little subjective, so if you want to throw a rotten tomato at me, you can, but this is what my experience is. Well, first off, you're going to benefit from 6 inches or larger aperture. Everything's just going to be better. It's all about, with the planets, there used to be a lot of talk when I first started being an amateur about, smaller telescopes, like a 6-inch was better than a 10-inch sometimes because the column of air you're looking through was much smaller, so you're much more likely to have better seeing, those brief moments of good seeing. And I kind of believe that for a lot of years, but in reality, that's really hooey. That doesn't really wash. The difference in the column of air, it doesn't really matter at that size. It's all about, with size, you get resolution and you get more usable power. Now, these numbers here are very subjective. These are my numbers, what I would use through a telescope. You can go above some of these powers on a really steady night, but you get to a point where you get a bigger object, but a lot of things with viewing, almost everything with viewing, is about contrast, whether it's deep sky or it's the planets. As you increase the magnification, you'll get a bigger image. And if it's a steady night, that's not a bad way to go, but your contrast will drop off a little bit. And a lot of times it's the very subtle things are because of the contrast you're seeing. So, but that's, once again, that's my opinion. But here's the ranges of the magnifications and stuff that you can kind of feel very reliable on the average night around here. It doesn't have to be a great night, but that's kind of like the average for working. This is a reminder for the Newtonian owners. Just the collimation. It doesn't matter if it's a great night and everything is just perfect. If your collimation is off, you're not going to see what you could see through that scope. And so refractors, this is not an issue. Schmidt-Cass's, you line them, you collimate them, they pretty much stay there for quite a while. Newtonians, I do it every time I go out, I check it and do little tweaks if I have to. I actually use a long focal length scope that the tube is close to 8 foot long. I actually collimate it in the position the planet's going to be when I observe it, just because if any movement at all, any torque at all, a fraction of a millimeter, I want it to be dead nuts on. So I will move the scope in the daytime to where the object's going to be, and I'll collimate it in that position. Okay, observing techniques. What is wrong with this picture? Is that you? Number one, this is all about quality of life type issues, observing quality of life. If you're gonna do planned observing and you're gonna use high power, having a tracking, some kind of tracking is the way to go, because it's immediate, it's a big plus. Whether it's an old style AC synchronous motor back here, 1/15th RPM, driving like an old Edmunds mount, a fancy clock driven, fancy brass mechanism with little governors and all, a go-to mount, or a Ponset table that will track it. A Dupsy put it up so you can track it. This is the second most. This thing, I only started using electric focuser 4 years ago, and I just can't believe I didn't do this eons ago. It makes such a difference, even with the best scopes, best mounts. As you touch the focuser to get that final focus just right, it always vibrates for it, even just a fraction of a second, even if it's just a little bit. And so as you look at it, you see it stabilizes maybe after half a second or a second. And you gotta kind of remember what that looks like, and you move it again. It's like, is that better than what I thought I saw before? Electric focuser takes all that out of the way. You just watch it come right into crisp focus, and you're dead nuts on. Now this is kind of an opal. This is a Rube Goldberg version. This is what I use, electric focuser. Typically, electric focuser, this motor would be mounted directly into one of these axes of your focuser. I have several telescopes, and I don't want to have gotten by a bunch of different focus mechanisms for each of the telescopes. So I bought a real cheap Orion, the cheapest Orion electric stepper motor I could find. And I got a little timing gear and a little timing belt. And I just have it comes with little bracket. On the bottom of the bracket, I put a Velcro, not your plastic and felt type Velcro, just plastic and plastic, heavy duty stuff that can hold, tens of pounds type Velcro. A little strip on each of my scopes. I have it on 4 different scopes I use this focuser on. And I just pop it off, and I can pop it back onto the next scope I use. So it's just a really convenient way of doing it. But electric focusers, if you have a 1-arm SCT telescope, which are very light and really nice, the problem is the 1 arm, and that instead of having a fork or some other mechanism or having a dovetail, this one 1 arm vibrates so much more. It's incredible. So it really needs to have electric focuser if you also to get, improve your quality of life tremendously. Eyepiece. Another subjective thing. I'm a firm believer in Plasso eyepieces for planets. I own some eyepieces that have 10 elements in them. I don't use those for the planets. Because every glass air surface, regardless of how well it's coated, you're going to get a little tiny bit of scatter, a little bit of light loss, things like that. And so if you have a lot of lenses, you got a lot of surfaces. And a 4-element Plasso seems to be the sweet spot. The Teleview Plassos, I just love. There's one back there, by the way, for sale. That's a 13 millimeter, but they are great. And so I find they give you everything's about contrasting. I think they give you a little bit of contrast because you have less scattering. And also, now it's kind of an old school thing. And a lot of eyepieces, when I first started, they were all like this. If you wanted a 5 millimeter, the eye lens was that big. And the eye relief for that, where the image formed, the eye relief was down to about 2-3 millimeters. I mean, your eyelashes are brushing across the lens every time you're doing it. In the wintertime, man, it fogs up so easy because the heat from your moisture from your eye would fog it. And it really was tough to use. But a much better solution to that is to use like a 12, 13 millimeter Plasso. Much lies, the eye lens is much larger. Eye relief is much more comfortable. Throw it in a 2-power or 3-power Barlow, and just so much more comfortable to view. Hints. Other hints. Basically, there's a couple obvious things people talk about. You put flocking paper opposite of your eyepiece focuser. So that part of the tube, particularly this is for like a Newtonian in particular. So that as you're looking through the lens, all around your secondary mirror, it's super flat black. Once again, it's all about contrast, right? So that's kind of the first thing you'd want to do. With all the lights around here, it's not that unusual to have a street light, a neighbor's porch light come on, or something like that. And that light could hit the end of your tube and just shine inside your tube a little bit, even if you have flocking paper. And every little bit makes a difference. So the idea to put a little extension tube. I make mine out of cereal boxes, but they last for years. And I just paint the inside flat black. I just slide them on. They weigh next to nothing, so it doesn't screw up your balance at all. A lot of the heavy ones that are much more rigid and will last probably a lifetime, but they're heavy. And this is very light. This is particularly useful if you're looking at Venus in the daytime. And also what I do, which is a more controversial problem, is I cap the end. Now, when I'm cooling it off, everything's wide open. But I'm going to observe, I cap the end. For two reasons. I have no proof of this, but I think it reduces the tube currents. It's my feeling. And also, once again, it's so bright around here, especially if there's a moon in the sky, behind the scope, the grass and everything. I mean, you walk outside, especially if there's snow on the ground, there's light coming at. Light's going up and hitting your secondary too. You're losing your contrast. So I cap it. I use shower caps to cap my scopes. So you can get little black scopes, just a couple bucks. Other things people use is filters. Some people love filters, some people aren't as crazy about filters, but each filter has its unique purpose. And if you have a set like that, you can play with all of them just to see what happens. On Mars, you can use typically use red or orange, but you can throw on a yellow or even a blue. Maybe with the blue, you can see some of the morning fog clouds, things like that. Typically, blue is light blue in particular, like this here is great for Jupiter, they say, and that's really good for Mars. The red. But anyway, there's different things, and there's some filter sets back there you can buy. I'm like a commercial here. And lastly, there's the ADC. Not as important as it was 2-3 years ago when it was critical, but an atmospheric dispersion corrector. The atmosphere acts like a prism, especially if a planet is low in the sky. So if you're going to observe and it's not very high, the prismatic effect is pretty strong. And you'll notice that, one side is red and one side is blue. That's just because of the atmosphere. It's just distorting the light. So it's not really focusing exactly the same. It's kind of giving a little bit it's almost like a chromatic aberration effect going in. This is really a strong effect. I don't know if it's quite this much, but if it's very low, with Saturn and Jupiter, the last couple of years, when they were much lower, this made a huge difference for me. Now, when it's up real high, Jupiter's up so high, once an object gets about 45 degrees or higher, the effect diminishes pretty quickly. But less than 45 degrees, it makes a difference. They're not real. They used to be really expensive, like $1,000 for one of these, but ZWO sells them now for about 130. So if you're an imager in particular, they're very useful. Okay, seeing, all about seeing. Okay, those nice cold fronts that come in and clear out the sky, especially in the summertime, it feels cool, it's great. Their transparency goes away if you blow away all the humidity, that's great. But the seeing is usually stinks. It's very rare to get a good combination of super transparent skies and super steady skies. They kind of work opposite each other. You can get lucky occasionally, but as a rule, when a cold front comes through or a major front comes through, for us usually it's a cold front from the west, it's not going to be great seeing for a day or half a day or perhaps more even. Seeing changes a lot. It changes day to day, changes from hour to hour. You can go out and say, wow, it's a great night tonight. Look 2 hours later, it's all mushy. You say it looks soft. It's just you can't pull it to a sharp focus. It changes. I'll show you some examples of that. But a good thing, but there are these moments of clear seeing. And a lot of times people, especially at star parties, will go and look, they have Jupiter in their telescope. They'll look in the telescope, 10 seconds, they walk away. 10 seconds, they walk away. Really, when you look through a telescope at the planet, you never want to look less than a minute or two and just really stare at it. Because there's going to be moments where all of a sudden it just clears up and it gets much sharper, but it doesn't last long, maybe half a second, maybe 2 seconds. And there's the moments you want to grab. And what'll help train you for this, you try to sketch it. Try sketching, try to make a sketch of Jupiter. It'll force you to sit there and look for those moments. And all of a sudden you'll see this detail, and you'll sketch it in, then you'll wait, and you'll sketch in another clear moment. But it's a good exercise. But it really will improve your what you can see on the planets. But seeing is everything. Your optics can be great, everything can be great. If it's a bad seeing night, it's going to be tough. Here's how it changes just in a short time over a given night. Now, these are just, this is a little video stack. They were stacked into one image, taken 35 minutes apart. This is really, really mushy. Now, this is kind of exaggerated. This is blown up really big because it's a video from a camera. Barely see the shadow here. 30 minutes later, though, a lot more detail going on here. You can see, you're gonna see a lot more. The contrast is up. That's in a 35-minute period. I don't know if I have, I'm not sure if it follows this slide. There's going to be a slide. I'm going to tell you now. There's going to be a slide coming up. Next slide or slide after that shows seeing in real time. It's an image of Mars. It's a video. When it first comes on, it's at its sharpest pretty much. And then it fades about 10 seconds. You'll see the image kind of deteriorate quite a bit. Not so it's after this one. But this is something, these moments of really small, clear thing, 11 seconds apart. One on the left, look how soft it is. The one on the right, much sharper. A person looks through a telescope on the left, sees that and goes, okay. The next guy in line looks in there, he sees the one on the right and goes, wow, that's really neat, you know? So it's you gotta have just that patience. Okay, now get ready. Beginning is sharp, it gets fuzzier in about 10 seconds. That's about at the sharpest. You can see, look at Certus Major there, and you can kind of see some detail around it. Then after a few seconds, you'll see it really gets crappy. This is so you're talking like 10 seconds apart, like we saw in that solar picture. And this is what seeing is. This is really blown up, so you wouldn't be quite that extreme as this is, but I wanted to show it as an example. And you can see it kind of come in for a little bit and then go away, and it's kind of varying. That's why it's a kind of a patience game. But that's what that's about. Okay, couple last slides. This is coming to an end now. Things you can do. Okay, you got to be the best you can get around this. Depending on your location, it's harder or easier. Watch looking above a roof. Roofs always get hot during the daytime. Always try to wait till it gets, if it's rising over your roof. In my house, it faces east of my house. I have to wait till Mars and Jupiter get up quite a bit higher to get themselves off that roof. Depending where you're at, grass is the best to set up on. So you have to watch the material you're on. Because if it's warm, it's going to radiate heat and give you problems. If your neighbor's having a fire pit, try not to, if you can avoid it, move your scope somewhere where you're not looking over, it's not under your object, even if it's 200 feet away, causing air currents. A lot of times there are 2 or 3 star parties a year. We do campfire star parties. Set your scope up on where the fire is behind you, not where you're looking. There's, look for watch chimneys. Chimneys really will go up a long distance. But there's factories and all around there. You look, try to avoid those things if you can move it. If it's by your house, that area of the sky is what it is. Planes have really gotten more. You can see in here how it's all like nothing. There's no detail at all where the engines are. I can tell if I'm looking at Jupiter, I'm going to image Mars or Jupiter. If a plane comes within a half a degree, I can tell immediately because that object just goes and just changes. It's not even close to round. It's just a fluctuating ball. And I know a plane went by. After like a minute, it calms down. And what you can control, store your scope in a cool location. My garage is not for my car. It's for a variety of telescopes. I keep them in there. It's about 10 degrees warmer than the outside air as a rule. So I'm pretty close to ambient all the time. When you first take it out, let it cool down. If it's in a warm room, you can't have a garage, you have a basement, it's cooler there. If you have it just in your living room, then just put it out earlier. Give yourself an hour to really cool down. And always try to observe when it's at the highest if you can. Because that's less atmosphere, less turbulence. You're going to get the best image. And that's it. So go out there, have some fun, and observe. Oh, next. I forgot to mention one thing. And I was going to mention, I knew there was
You were
something else
next. Yeah. You want to go next?
All right. You want to go next? One thing I was supposed to mention. The club has just got a camera for the rental department. and it's available. It's a planetary camera. It's a CWO. It's a 385. It's got a 3.75 micron pixels, which is good if you're a planetary photographer. It's a very nice planetary camera. If you ever thought about fooling with it, this is a way to go. You can just rent this out for a few bucks a month and give it a try to see if you like planetary photography. Anyway, it's available in the rentals.
All right, next up, we have Wayne Reed. He's going to talk about solar imaging.
Got a fan club.
Yeah. Okay, we'll talk about the sun, how to observe and photograph it. This is a little,
Wayne,
yeah,
you're not coming on the mic.
oh. Okay, is the mic turned on? How's about that?
What?
There we go. Now I've got it. Okay, so I'm not interested in the structure of the sun out in the inner parts, but the important thing for observing is the parts that are visible, which is the photosphere, which is all of our daytime light comes from, and the chromosphere, which is a very active layer above the photosphere. The corona is also interesting, but the only time amateurs can see that is during a total solar eclipse. So that's not something that we normally observe. Let's see if this. Okay, the choice is white light versus hydrogen alpha. Two ways to observe the sun. White light uses a continuous spectrum from the photosphere surface. The main thing is it has to be dimmed down in order to see it safely. Hydrogen alpha uses only one specific wavelength of light. It's a deep red color and it's emitted by the more active chromosphere layer. So here you can see an example of the photosphere with sunspots, and above that is the chromosphere with sunspots and flares and prominences that are visible that way. This way, okay. White light, first of all, this is an image from a website called Gong. They have telescopes around the world, at least a half a dozen or so, and at any one time, there's got to be one or two that has a real-time or close to real-time image, so you can preview what's available at the time you're ready to observe, see whether it's worth going out or not. So this one is white light. You can see sunspots on there. The filters block 99.99% of the visible light, so it's safe for your eyes and cameras. They're made typically with reflective coatings on plastic film or glass, or a plastic film that has a black filler throughout the film. The view is usually white to slightly bluish through the coated fillers and yellow to orangish through the black polymer fillers. The filler cells that you can use to attach the film-based filler to match any optical equipment can be easily made or purchased. And I have a couple of examples that you could see after the talks. This is a filler made for the solar eclipse using cardboard cut from a cereal box and some foam core. Cost was essentially zero. And another one that I made years ago for another telescope using the black polymer film, and I made it out of plywood. There's a lot of different ways to make your own, very easy. And the Bader, so here's some equipment. The Bader film, which is what I use for these, comes with the directions on how to make the pillar cell. So this is my setup for the last total eclipse in April. And I had a filter on the telescope, the same kind of filter on the camera, and 2 filters on this binocular rig. And my wife was using another pair of binoculars that had filters that I made out of plastic pipe fittings. So there's all kinds of ways to do it. And targets for white light photography. Sunspots are the main thing. As you can see, they tend to have a gray area around the outside and a black area in the middle. And also there's a texture to the sun, which they call granularity, or they're convective cells where the sun surface is sort of boiling. And if you have sharp enough resolution, you could make that out. This I took in doing the last total, or the last solar maximum in 2000, in 2003. The sunspots are kind of rare during the minimum phase of this sun cycle. They're very common right now. Like this picture up here is showing a few days ago that I got that off the website. And another target is transits. Mercury and Venus can transit the sun. This is a transit of Venus going towards the edge of the sun in 2004. We're not going to live to see another one of those. It's a little under 100 years from now is the next one. But Mercury is going to transit in somewhere around 7 years, I believe. Another target is solar eclipses. The white light filters are essential for that. This is a shot that I've shown before. That I used the filter for the images around the outside, and then the total eclipse is there where you can see the corona. And I show this frame, especially, I think it's cool because you can see a prominence, which normally you require hydrogen alpha telescopes to see that. But in total eclipse, they can be visible to the naked eye even. And these were shot with a monochrome camera, so there's no color. But in reality, this was pink because it's hydrogen alpha light, which is red, combined with the light of the photosphere, turning it pink. So, another target is transits of satellites. Satellites occasionally will cross in front of the sun. This is this ISS, the International Space Station, crossing back in 2006. The camera that I had at the time got 4 frames as it passed. And this is a shot from the same pass. And Gary Trapezzano was shooting the same thing from about a quarter mile away, and it shows the parallax between the two. Luckily, we had some sunspots that made it easy to line up the images. Now, the other side of solar imaging is the hydrogen alpha. There's other ways of looking at the sun, like calcium and all that, but this is the most common alternative, where you're looking at the light emitted by ionized hydrogen in the chromosphere. And here's an example of the gong view for that same day as the white light shot, showing filaments and prominences. And some light areas and so forth. Let's see, the hydrogen alpha light isolates the fainter light it's normally overwhelmed by the intense light coming from the photosphere. So you need the specialized filtration to single out the one wavelength that this is producing and block the rest of the light from the sun. And it's a deep red color, one shade, so it's monochrome, and there's a wavelength for it. The width of it is critical. You have to have between 1 angstrom to a half an angstrom of width. So you gotta be real specific and precise with that. So that requires filters called an etalon. And because of the precision, all the hydrogen alpha telescopes and filters require a way to tune the filter to hit the exact frequency you need. You know, the etalon is a special type of filter that they use. It's complicated and it makes the telescopes and filters a lot more expensive than white light filters, especially like these, which are next to nothing in cost. But the view is, in my opinion, more interesting. Here's the equipment that I use. This is a Lunt telescope and it's pressure tuned. That's what this knob is down here. That's actually a piston that as you turn it, it compresses the air inside the etalon, and that tweaks the index of refraction, refractive index of the air inside there, and that changes the frequency. I have a 2.5 power Barlow there, and a camera. This is a ZWO camera, 174 monochrome camera, and there's a tilter on here that I've found that helps with some issues to be able to tilt it. And I'm using a Star Adventurer mount, which tracks fine for this purpose. You don't need long exposure, so you don't need guiding or anything too elaborate. Here's an example of the sun with the equipment that I was showing. This took 6 frames of the surface of the sun and 6 frames of the outside, 2 different exposures, and combined into to show this view. The filaments like this are the exact same phenomenon as the prominences you see here. The prominences are lighter, they're cooler than the sun's photosphere, so they're darker, and that's why I had to use a special, a longer exposure in order to photograph the outer surface, and that these show up darker against the bright photosphere, or the chromosphere actually. And then you can see some sunspots in there, the black spots, and sometimes flares. Here are some examples of prominences. They're fascinating. They're always different every time you look. And even at solar minimum, there's good chance of prominences. And this chart gives some examples of types of prominences that you might see. And here are some that I've photographed. This may look a little confusing, but this arc is the edge of the sun. And, you know, the sun is big on this scale, and it's blocked out by a black disk so that all you see is the edge. And the blue dots I did here are scaled for the size of the Earth. So that gives you an idea of the scale. This is one of my favorites here because a chunk of prominence is detached from the sun and heading off into space. This one you'll see again on another slide here, but you can get a sense of just how big it is compared to the Earth. Here's one of my favorites I did right around October in right near Halloween in October 22nd, 22. And as you can see by these blue circles, it's at least 6 times the diameter of the Earth. So that's a big prominence. So I thought it was a Halloween goblin coming over the edge of the sun. I showed it to a relative, and she said, no, it's Hamilton. So I didn't expect Hamilton to come over the sun, but that's... Now here's that other one I showed you, and I did a little time-lapse video, and this represents 26 minutes of activity. So I took a whole bunch of videos, combined them to make a little video, time-lapse video. And so you could get a sense of just how fast things are changing there. And imaging, it's best done by recording a video of short exposures, typically 1,000 to 3,000 frames. Then you have special equipment or software. Fire capture is free. SharpCap is free in its normal basic version, and those work really well with astronomy specific cameras like the one they've got here and the ones I use. There's also software for other cameras such as Backyard EOS. I've used that for a Canon DSLR. Then when you get the videos, you process them in an auto stacker. That's the most common one that I know of. That's another free program. It's amazing, all these fantastic utilities that are free or inexpensive. Auto stacker will align the frames so that they're all exactly on top of each other. It grades the quality of the frames and sorts them by quality. And then you can have it stack the best to make it one image. And that helps reduce or improve the signal to noise ratio. These can then be processed through Registacks or other utilities to sharpen and contrast adjust the image. And then Photoshop, Affinity Photo, or GIMP are common programs that you can use to do final processing, compositing, and colorizing. By the way, all of this is relevant for white light and hydrogen alpha. And since prominences are cooler, you need more exposure to get those. So you use like 3 to 5 times the exposure to get the prominences. So you can choose to photograph the prominences or the surface, or you do both of them one at a time, and then you composite them to get both of them. But you can take the sun surface and block it out like I did on that other slide, where I hid the surface of the sun, which was just white, like you saw in the video of the active sunspot. The sun is overexposed. So a black circle can block that out. And finally, there's some choices after you do the rest of the processing. You have options on how to show your work. Since the sun hydrogen alpha is one wavelength of light, I use a monochrome camera, and so the result would look something like that. That's the finished grayscale that I would get from the camera after I process it in this case. Now here I colorize it to try to simulate what you would see through the eyepiece. It's really a deep red, and the human eye has a hard time seeing subtle features in all red like that. So what we typically do is either show a grayscale or colorize it. This is colorized in a palette of red for the darkest parts to yellow for the brighter parts. And that lets us see some of these filaments stand out nicely, and there's a lot of detail that you can make out that way. A common thing I've seen a lot of people do recently is invert the surface of the sun so it's a negative, where the filaments are now lighter than the surface and light spots are darker, and it makes those filaments sometimes look very three-dimensional, which is an interesting effect. But it's all a matter of personal choice and your artistic purposes or whatever. The idea is you're showing more detail than you can see in the red that it's emitting. So that's what I have to say for today. You can go to the next person.
All right, thanks, Wayne. That was great. Next up, we have Joe Lamb, and he's going to tell us about the moon.
Everybody, how are you? I'm up here tonight to talk with you a little bit about capturing the moon and talk a little bit about lucky imaging. So see how it goes. These are images from the astronomy textbook that was written while I was in grade school. Now I'm older than probably most of you, but you know, these images were taken with the largest telescopes in the world at the time. The image of Saturn was taken with the 200-inch Palomar telescope. And while these images are really, you know, wonderful and scientifically very valuable, to look at them, you have to think, gee, you know, they perhaps don't measure up to today's standards in terms of what we can do. And it's because they were snapshots, you know, and although these were the greatest telescopes of the world, you know, and miracles of engineering, you know, they couldn't control what was happening to the photons in the last few miles of their flight into the atmosphere. And because of that, it was just like, you know, a guessing game as to what you would get. This is a lucky image of Jupiter taken through really, really poor seeing. It was probably like 2 or 3, you know, arc-second seeing one night. And I was just kind of testing out a camera. And I took a 1-minute video. So at about like 100 frames per second. So this has like around 6,000 frames. And so I put it in software for lucky imaging. And in about 17 seconds, it showed us like the best image, the median image, the worst image, and stacked every one of those 6,000 images. So you can see, excuse me. So there's the best, the median, and the worst of those images. And if you notice back here too, the images themselves are rather noisy. And that's because in 1/100th of a second, you know, some of those little photo sites on the chip are going to get more photons than others. So the noise is kind of evident when you take a single, but when you stack them, the noise kind of goes away, it gets averaged out. So that's about a 2,000 frame stack of the resulting image, and putting in sharpening program, that's the result. And it's not a great image, but you know, for 2 or 3 arc-second seeing, it's just amazing compared to what our predecessors had to go through, even with you know, even with the largest telescopes in the world. You know, we have such an advantage over them. It's just crazy. So shooting liver images, you know, have certain advantages. One of them is light pollution is not an issue. You can shoot great from your backyard. You know, we don't have to worry about going to dark sites, and you know, and the moon is out all the time. You know, it presents a relatively easy target. It's large, it's bright, it doesn't rotate, so we can take really long videos. These are 3 popular programs for capturing and processing lunar images. Fire capture is used by a lot of us, not all of us, but a lot of folks. AutoStacker 4 is great for stacking images, and Registack's great for the sharpening of those images. So there's no real requirements for shooting the moon, but there's some things that really help. And one of them is good polar alignment. That's really, really critical, because you're looking at the moon, you're looking at it through a computer screen. You know, if you have good polar alignment and your mount can track, you know, that image just stays stable, and it is really quite an advantage. And automatic focus controls, as Tom mentioned, are really helpful too, because sometimes, you know, the atmosphere is really dancing, and you're trying to focus the image at the same time, and you know, you're thinking, geez, you know, is that the seeing that's changed? Is it what I did to the image? And you're under pretty high magnification, so everything is shaking. So having an automatic focus control is really kind of helpful. And if you have a mount that has a lunar tracking rate, that's really helpful too, because the moon moves a little slower across the sky than the planets and the stars. So and also if you are stacking an autostacker, it's a little different than planetary in that you should indicate like surface, not planet. Other than that, it's very, very similar. Monochrome sensors are slightly better in resolution and throughput than color sensors, but they both work great. Monochrome sensors do work a little bit better sometimes with filters. Both times work great. If you have a color sensor, use it. You know, if you have monochrome, that's good too. This is what I use. It is what Wayne uses. Tom uses the same camera. It's a very, very popular camera. It's been out for a long time. Z20, ZWO 174. It's our great monochrome camera. Color filters really are helpful in reducing refraction, atmospheric refraction. If you use a color filter, I generally use a red filter. Red filters are useful also in reducing seeing effects. And I use a red filter quite a bit. I've also started using an infrared ZWL 850 IR filter as well to try to reduce the seeing effects. But you don't have to use filters. You can just, you know, do it without. The red filters seem to work fairly well for me. This is my rig. One of the best decisions I ever made was to mount a rig. You know, my mount permanently mounted outside. You know, you just go out and it just makes it easy setting up every night, not worrying about power alignment and whatnot. And it even allows me to shoot indoors when the weather is inclement. I put a little pool noodle in the window and use USB extenders so I can set the you know, set the computer up inside and stay warm when it's really freezing out. And I think it makes it a lot easier on the computer too, not having to deal with the cold and the heat. So these are just some monochrome images taken with the 174 Copernicus crater and Marion Bream. A shot at F20 with the SCT. Positonius. That's on the edge of Maris Serenitatis. Southern Highlands. You can also mosaic your images, and that's a lot of fun as well. You can use free software. I've used Image Composite Editor, which is made by Microsoft. It's a free program. I've tried others. Some of them are really difficult. This is a really, really easy one to use. And I've been using that with some success. So this is an image that I did, I guess about a year or two ago of the moon. These are the individual frames, 150 frames. Everybody thinks I should go back to work. You know, maybe I should really see somebody. But I shot this over about a 3-hour period inside the house about a year or two ago. And these are most of the images. I had to make sub-assemblies because the program wouldn't really stack that many images. So I had to make these little sub-assemblies. And the images were so small, like a lot of times I couldn't figure out what they were of. So I had to go to the atlas and figure that out. And then I had to like rate them where they were. It took about 2 weeks. But these are just the sub-assemblies. And that was the final image from that. But overall, it's a lot of fun and you know, it's you know, so this is the image. And the nice thing about the composites is you can enlarge them and they don't break down quite as much as an individual image would. I shot so many images because I saw this video of somebody that did this thing and put hours and hours and hours of work into it. And he realized at the end he had missed like one little image. So he had to put it in Photoshop and then, you know, and that kind of freaked me out. So I kind of overlapped him a lot more than I really should have. So just some ideas, you know, when you do these, you should record them all at the same exposure, and you should set the exposure on it to the brightest lunar feature first. Because if you don't, if you set the exposure time on something dim, when you get to the bright area, you'll overexpose it. So, and then you just sharpen everything similarly in Registacks if you use Registacks. And it's good, like I recorded this on an external drive because it'll fill up your computer like crazy, all the videos, not the individual images, but the videos, just like your computer will just like die. So I used an external drive and just went directly into that. And you can enhance the lunar color, as well. The moon has a fair amount of color and we don't really realize it, but there was a great article in Sky and Telescope, I think last March, that really talked about that and how some visual observers actually see color in the moon. In fact, there was a sea star image that I saw a couple of weeks ago where you could see color in this in the image that the sea star took. It showed color in the large frontalis area, the bluish titanium lava flows. So this is one that was colorized. And the way I did it was I shot a monochrome image and then I shot just a regular color image with a Canon camera and I put it in layers. So the top layer is the detail and the lower layer is just, the blurred color image, and then just selectively added the color to the moon. So it's kind of like the best of both worlds like that, because you can keep the sharpening and add a little bit of color so you don't lose detail. So and you just add it. This is just an old copy of Photoshop. I got this years and years and years ago. I don't have a subscription or anything like that, but I would think that GIMP and some of these other programs would kind of do the same thing. So these are just some recent, just Tycho. Schroeder's Valley and the crater Aristarchus. And composite images can be color enhanced as well. So these are just two images that I took recently that I thought the subject matter was kind of cool. And one is the western edge of the Southern Highlands. And you're probably all familiar, those of you who are lunar observers, of these craters. This was taken with just my 174 camera. So I'm sure many of you will recognize Ptolemaeus and the others.
So was this most of the frame that you captured?
Yeah, that was about the entire frame with 174, just a single frame. And near Mare Nubium, like on the left side of the frame. But the crater that I was kind of interested in was Alphonsus, because it kind of has a cool history, And this is 1 arc minute, 72 miles in diameter. It's about 1 arc minute on the moon. This crater was visited by Ranger 9. Ranger 9 was one of the 3 programs that NASA had to investigate the moon before they sent a crew up there. And Ranger 9 had a 2.5-day mission where they just sent it up on an Atlas, a Gina rocket, I guess. 2.5 days later, it crashed into the moon. But in the 13 minutes before, or 19 minutes before it crashed in, it took 6,000 pictures. And the last picture showed details that were only like 10 inches apart. So it was kind of remarkable. But they were scared to death of what the moon's surface actually looked at. And this is one of the programs that was trying to find out information on all that. But Alphonsus has had a history of transient lunar phenomena, glows or gases emanating that observers have seen. And one of these observers was Dinsmore Alter, who was the first director of Griffith Observatory in California, in Los Angeles. And he created a lunar atlas. And he worked nights with the 60-inch telescope at Mount Wilson. And one of the nights he was working on this, he saw a transient phenomenon in the crater Alphonsus. And this poor guy, Nikolai Kozyrev, was one of the Soviet Union's greatest astrophysicists. He was a prodigy, and he was coming along, and unfortunately, he worked at Pulkovo Observatory, and he was subject to one of Stalin's purges, in which the entire staff of Pulkovo Observatory was murdered. And he got a 10-year sentence and then another sentence on top of that. And they were getting ready, I think, to execute him. And somehow he had friends in high places and he was able to get out and try to salvage his career. But in 1958, he recorded a spectrum of gas, diatomic carbon, I think, coming out of Alphonsus. So it kind of is an interesting crater. There's been other transient phenomena in other parts of the moon, but Alphonsus is kind of like the poster child for that kind of thing. And if you'll notice in this image that's coming up, there's these dark mantle deposits that are on the surface there. Let's see, I don't know if you can see them. I don't know if you can see them here. Some people think that they're just mantle material that was excavated when different meteors hit, but there are other people that think that these are volcanic and possibly the source of these transient phenomena. So I thought that was kind of cool, and I attempted to capture that with the camera. The second one is the Apollo 17 site, and I'm sure many of you look at the moon and show people at the star parties, the Sea of Tranquility, but right up the street from that in the Sea of Serenity is the Apollo 17 landing site. And that's an interesting place. And it's right on the edge of the shore of Mare Serenitatis, which is right about there on this Google map. And the area is called the Taurus Latrobe area because right there on the edge is the Taurus Mountains, and then below that is the crater Latrobe. And this is the Taurus Latrobe site, the landing site. That's just an enlargement of the map. You can see the Apollo 17 site there. And it is bordered by two giant massifs, and they kind of formed, interestingly, like the moon, I guess if it looked like this pre-impact, when the meteor scoured it out, it threw up these two massifs. And then later, as you know, these areas flooded, including the area between those two massives. And then finally, a fault developed there, and then this landslide. And the landslide, they thought would contain old crustal rocks from way back when. And they were trying to, on Apollo 17, that was the last ditch effort to try to age like the moon. So they were looking for the oldest rocks they possibly could. And they thought that they could probably find them right there where that landslide was. And they also knew that they kind of felt that there was going to be some volcanic activity there, and they thought that that would be a source of younger rocks. And the reason why they wanted to do that was because on the moon, they have these old rocks, but on the Earth we don't, because of erosion and also because of plate tectonics and subduction. We've lost a lot of the old rocks. There are very few places in the Earth that have rocks that are really old. So they know that the moon and the Earth more and more now, they know that they formed together because of certain lines of evidence. So by dating the moon and getting the oldest rocks on the moon, it kind of gives us a clue as to our history. So from the surface, when they were on the surface, it looked like that with the massives, North Massive and East Massive and the sculptured hills. This is looking north from where they were on the surface. From Lunar Reconnaissance Orbiter, a satellite that orbited the moon. The site looks like this. You can see the landing site and the massives and the landslide that they investigated. And this is the shot. Now I really pushed this shot, but it was taken with the MCT, and with that, you can see a little bit of a landslide. And you can even see that little fault that was running through there. Just the evidence of that a little bit. So all in all, it's just amazing. I think, the technology that we have at our disposal that, previous generations didn't. And And I think it's a great thing. And we do have planetary cameras. So if you guys ever want to try this, we have it here. It's the clubs. You can take it and use it for a month or two. And if you're thinking of trying, photography like this. So. Of course, none of it's as good as being in orbit. They're the tracks of the last people that walked on the moon. And they Apollo 17 landed 52 years ago yesterday. So today they'd be doing their EVAs. Pretty amazing, they spent a lot of time on the moon. They were 3 days on the moon. They traveled about 35 miles in a lunar rover. They got as far as 4.7 miles away from the lunar lander. Can you imagine breaking down 4.7 miles? And from your ride home, that'd be pretty scary. But yeah, so thank you so much.
Thanks so much, Joe. How long would it take to hop the 4.7 miles back?
Yeah. In 1/6 gravity, though.
I don't think AAA responds out there. All right, our final presentation will be by Tom Skrvanek, and that will be on planetary photography.
Okay, is it on the screen?
Yeah. And that's the laser. Okay, great.
Okay, my name is Tom Skrvanek. I am a member of this organization since July of this year. Before that, I have made a couple of visits, just meetings like these, and I also went to a couple of star parties, and I really got interested in planetary astronomy, photography. So here's 15 slides, 15 minutes, hopefully, before you fall asleep, to show what I have done and the kind of struggles I have come across, and some examples of pictures I've taken. So my equipment is actually in the pocket here somewhere, but it's also there. It's just a Google Pixel, 3 generations old, and the adapter that allows you to put the phone over the eyepiece and exactly center it. So you have 3-axis adjustment. And my telescope in my backyard is a Newtonian 10-inch if focal length, 1200 millimeters, and you can see 4.7, and it's sitting on a Dobsonian mount. So I'm going to jump you right into the process. So you'll see some of what the experts are doing, but I've learned this just by YouTubes and talking to a few people, John and Tom and Joe, and here's what I'm doing. Where does it go? Sorry.
Down arrow.
Yeah. Okay, so the process is called drift photography, or lucky, a subset of that. And this is what I go each time I try to do this, take a picture. So my telescope is inside, so every time you bring it out, you have to wait until it adjusts itself, the mirror. So you have to collimate it. Invariably, I will hit it and bump in. So adjustment is always necessary. Then I take a low power eyepiece, and I try to locate the planet. Well, so far I've done Moon and Jupiter and planets, so it's not so difficult to find. Then once I have the eyepiece aligned with the attachment, then I put it in and I adjust the exposure so I can see on the screen, so it's bright enough. Okay. Then I locate it, so then I have to focus the telescope, which is a challenge in itself. Then finally, I want to have an image it's on a screen of the phone, a challenge in itself. I zoom in, basically just pinching. Okay. So it gives me a magnification around 500, 600 or more. So it's quite large. Then it's time to adjust the ISO and the exposure, so you can have an image that shows some detail. Again, refocus the telescope, locate the planet somewhere at the edge, start the video, and just let it drift. So you get I get about 15 seconds of the image drifting across. Then I stop the video and go back, reposition the telescope, start again. So I keep doing that until you have, I don't know, 10, 15, whatever number of individual videos that they can be processed. So then they come out as MP4 files on this phone. And by the way, I was not using the Google built-in app. It's a separate app that emulates a DSLR, so you can adjust basically manual adjustments. So here's an example. I don't know if this will play or not.
You might have to click on screen.
Click on screen. Maybe. Yeah, so this is what you see. And this is just an example. I'm not saying this is the one I actually use, but I just showed that, you know, about 15 seconds, the planet is gone. And you start over again, which can be quite a pain after a while. How do I advance it? Okay. So then you process the MP4 files. So it's stuff that we just heard, and there is the MP4 files have to be chopped up into individual subframes. Okay, that's the first preprocessor, and you also align the image so that the image sits in the middle. So you get rid of the drift. Then you stack. The auto stacker selects a given number of best pictures, it arranges them in order, and then as a further complicated process, I don't want to bore you with that, or probably already know how it selects each individual subsection of a picture and combines it. And after that, you have an image that you've seen some examples, and you can use Registack or a different software to sharpen it, filter it, so you get the final image. So here are some examples that can be obtained. This is just using the cell phone and the 6mm eyepiece, and just so these are recent pictures. Here's a moon. I don't know what it is. I thought moon was made of cheese, according to Google. I don't know if you guys remember when there's a Google Earth, there's also a Google Moon. Have you ever looked at that? Well, before Google lost its sense of humor, you zoomed in on Google Moon. Eventually, it will show you Swiss cheese. Yeah, that was pretty funny. No more. Okay, so some of the challenges. This constant reposition of telescope is really annoying. I mean, it's almost a deal breaker for me. Plus, the Dobsonian telescope I have, the mount is quite poor. It has a lot of stiction, so you try to move it, invariably overshoot, and it's a big struggle just to get it to the edge, get the high magnification. And focusing is also an issue. You've already heard about that. So how was I trying to address? So I looked around YouTube and searched and what people have done. And so a potential solution for Dobsoni is something called the equatorial platform. So imagine that you point as a cone at the North Pole and you rotate it at 15 degrees per hour, opposite of the Earth rotation, then anything that sits on that cone will track. So you see the bottom part is kind of flat. You can put a platform there and let it rotate for a little bit, because you can put a telescope on top of that. And you can rotate it, and it'll follow the rotation until it would eventually flip over. So you have a limited time where you can do that safely. So here's the kind of implementation. You take a partial of those arches, front and back. So these will be the edge of the cone, and here's the axis, and you put a telescope on top and you rotate it, and you have tracking, at least for a while. So here's see this will work. Kind of a diagram of what that thing looks like. You can project those circular arches down vertically with some trigonometry, and you can build a platform that's kind of works like this. So your telescope is sitting on top of that, and you could make these arches longer, but your telescope might forward because the center of gravity has to be above the top. But still, you can get half an hour of time to observing. So I looked around and decided eventually to build one. You can buy one for between $400, maybe $1,200, some really nice ones. But anyway, this is something I found by this guy, Astro Fields of YouTube. He's out of the Czech Republic. It's my neighbor. I'm from Slovakia, so I like that. So this is with something done with jigsaw and screwdrivers and so forth. And I brought an example that's sitting in the back there if you'd like to see it. So this end would be this end will be pointing north, and it has to be leveled, right? So when you first try observing, you have to level it, aim it at Polaris and so forth. And then you can put the telescope on top of that. So here's what it looks like in slow motion. It's driven, right. It's driven by a motor that's over here. You can adjust the speed a little bit to match the rotation. And it has to stop. There's actually a little switch that shuts it off because I've had this telescope almost fall over because it just went right over the edge. So the example of that, we saw what happened before, where you have moving like this, and on the right side is tracking. So you'll sit there for 10, 20 minutes or as long as you want, depending on how well you align it north, how well the horizontal is. The critical part here is that so the arches have to be made exactly for a latitude, 40 degrees. They're kind of like a squashed eclipse. So the circle gets squashed through geometry. Okay, so the other issue I had with this mounted of the telescope, initially it came with this base and this the telescope is on top of that, and it was just rotated on these Teflon pads, and that was just unbelievable. So I put some soap around it and try to make it smoother, but it is a pain. Still, the stiction is just too much there. So I have this, I cut out this circular board and I put a bearing, Lazy Susan, you probably know what that means. And now the telescope is riding on the bearings very smoothly. So that problem has been solved. The other issue was this focuser. Tom showed a motorized focuser, which I have to figure out how to do, but the focuser here is really rough, so I made this out of spare 3D printer parts, this kind of a gear and belt, and so you rotate this 4 times before this rotates once. So at least you have a finer focusing, but I think I'm going to have to hook up some kind of motor because every time you touch this telescope, it just jumps all over the place, and really frustrating. So my future plans, well, I'm using a phone, so I'm going to buy. Actually, I already have bought a camera, proper camera, and I'm going to use the SharpCap software on the PC. And like I said earlier, I have to figure out some way to do the focusing without touching the telescope. And also, I'm considering to put some kind of fan here on the back of the scope so that it takes a little bit. It doesn't take as much time to adjust the temperature, so you can take it out and pretty quickly start observing. And the other issue was, so I've solved the horizontal rotation, but the ultimate is still an issue. If you don't have a balance tube, it's just, you have to be very tight, and then you get stiction there. So these are the kind of things that I plan to do, and hopefully I will be, aspire to make pictures like Tom, which is amazing. We watch this guy from Agapios from Turkey, and I think Tom's pictures are better than his 20-inch telescope. It's amazing. So I aspire to be, one day when I grow up, I'll be like Tom. Anyway, so if you like to see the platform, and if you're interested how to build one, to me that's without that I'm not taking the telescope out except maybe for visual observation. That's all I have. Any questions?
Thanks, Tom. That was a great presentation. They were all great presentations. Any questions for Tom or any of our speakers?
It was self-explanatory.
Actually, I have one for you.
Okay.
How the heck do you polar align that thing?
I use a compass. just account for the declination.
Head north.
You know, it's not that critical, right? Because we were shooting movies, especially Saturn and Jupiter, like Tom showed. In 4 minutes, you have so much movement, which will result in image not being sharp. So you're talking minute, right?
Yeah.
I mean, it's not that critical. But if you get lucky, it just sits there, you know, half an hour.
Hey, Tom, I have a suggestion for you. If you're looking for a counterweight, you get a Harbor Freight and they sell, Harbor Freight sells magnets, about a pound each. I had a scope just like that. And you can just put felt on the bottom of it and slide it up and down as you need as a counterbalance in the tube. I also put, to prevent some of that stiction, I don't know what you call it, but it's sometimes you see this on the wall in the bathroom. It's like vinyl and it has bumps all over it. It acts like like a to relieve the friction in the ball bearing. It moves really smoothly. So get new Teflon and
Bearings, they just move so easily that when it burns it. So I put some carpet pads, I mean, we try to bring some of the station back. So, yeah.
well, I mean that's stuff I tried. I've never done it, so I really wish I was fine. You may need to.
So you could have a real scope and do actual astronomy.
It's a lot of fun.
Mark, you have a question?
Yeah. Well, I can just talk loudly.
I don't have a question as much as I have an observation. I am absolutely gobsmacked by the talent of the people here. Not only are you incredibly talented and gifted, not anybody, people can do that. But to be able to humble yourselves to say, so-and-so is better, so-and-so can do this. And also to be able to make it to a point where you can communicate with, so to speak, the average Jane or Joe. It's a gift. I've had the pleasure of being married to someone I affectionately refer to as Mr. Science. Science is not my background. It's not my strong suit. But I've had the blessing of being able to know any number of you individuals, and you talk to your audience. You make sense in real time to us. You let us ask questions, couch it in the ways that we do, and you make it accessible. I'm not saying I'm a rube, but I am impressed that you folks have that ability. Thank you very much.
Thanks, Barb. Any other questions? All right, Tom, you want to tie the ribbon on?
Not from here.
Well, thank you, everybody. Thank you to the presenters and thank you all for coming out in this cold night. And have a safe drive home and I'll see you next month.
Thank you. Nice.
I read it.